The logic of the transfer from the model world to the real world. The maximum would be assumption A, which is probably false, right? So let's see how we can analyze that. So to come back again, that you really see the contrast. The usual framing of the logic of the model explanations is we have premises containing the model and its results, and the step is then, by this arrow, explanatory conclusions for the real world. This is what we want to do. And the question is that arrow there, that's, so to speak, this logic, is this transfer. How does it work? Inductively, abductively, whatever. Okay. The problematic transfer from model to real world. And I mean, Sugden is absolutely right in his article and is wonderfully clear how he identifies the problem and then criticizes the others. But let's see. Okay. Now what I'm going to do, I give you a radically different framing of the logic of the explanation by abstract models. Framing is a technical, became a technical term, also now in almost an everyday language. So the question, how do I frame a problem? Meaning, in which context do you put the problem? Right? So for instance, different schools in, say, psychotherapy have different framings. For instance, the framing in psychoanalysis is you look at the individual and its history. And if you go to a systemic therapy, say with family members, then the framing is you put that individual that's working with you or you're working with, you put it in the family group with mother, father, uncle, and so on. And then that's the framing of the problem. And then you try to understand what's happening in that group, in this family. And so you have that in many cases. It's just the point of framing the problem. Also in political contexts, of course, you have to frame problems typically then in a certain historical way. So this is what you see today in the conflict between Ukraine and Russia, that Putin and the Russian elite there frames the problem in a certain way by saying, you know, historically, Ukraine is really a part of Russia, and it always belongs there. It's not really a state, you know, it's not really it doesn't have the right to be a state. And from the framing, from the historical framing, he then claims that it's a part of Russia. So what he's doing is really something completely legitimate. And of course, other people frame it differently, and they frame it then, wait a minute, after the decay of the Soviet Union, Ukraine became an independent nation, and they now developed, you know, a nation identity, and they developed in the direction of the West. And in that framing, then it looks completely different, looks completely illegitimate what Putin is doing, because this is a democratic country. Well, they have corruption and all sort of different things. But anyway, so you frame the problem differently, and then the problem looks different, right? You have the same in many political and individual situations. So it's very important also in philosophy, of course, also in science, in economics. The point is simply how you frame the problem. So because that already determines much of what you can do later, and especially what you cannot do later. So what I'm proposing here is a radically different framing of the logic of the explanation by abstract models. So what Sugden does, he does it in this classical way that he says, you know, we have here premises, you know, containing model and model results. So we learn something in the model world, and then the question is how can we transfer that to the real world? There is also, I think, I gave you the paper in OLAT, the explanation paradox, in which Julian Rice, the philosopher of economics, wrote, you know, we have a real paradox in explanations in economics. Why? Because in the premises, you know, the premises containing model and result, the model is really false about the world, right? The model is false. So what we have in the premises, a false premise, and then we want to have an explanation. But usually explanations don't work from false premises, right? They work from true premises. You have a true premise, and then you can explain something. But when you start with a lie or a falsity, you cannot explain anything. So he says, wait a minute, this is very strange. You know, and that problem is, of course, a result of that framing. When you then say, well, the model is false of the world, it's an idealization with no end, so even in that case, absolute substitution. You know, the Schelling model with the chips, that's exactly what Friedman is, a substitution, right? You substitute people with real preferences, blah, 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 living in houses, blah, blah. You say, I don't care, substitute that, because I think here the preferences, the racial preferences are the main causal factor. This is how Friedman rightly would describe that. But that's, of course, false. It's absolutely false of the world. And therefore, we start from false premises and explanatory conclusions. And therefore, Julian Rice wrote in this paper, 2013, I think, he wrote, well, there's a paradox. And then people said, later papers then was widely discussed, and then later people said, well, this is the real problem of philosophy of economics. We've got to solve this explanation paradox. Why? Well, economics is so dependent on the explanation by models. And if we don't understand this paradox or resolve it, we are really in a very bad shape. Anyway, so I propose a very different framing of the logic of the explanation by abstract models. If when you hear it the first time, you will say, unfortunately, some of these teachers and professors run out of their mind. Okay, so the main claim is, and this is already perhaps somehow strange, the purpose of the investigation and the robustness analysis of, for instance, the Schelling model is something very different from what you expect and what I did not expect, and you may not even understand what I'm saying here, but I'm going to explain that in detail. To support inductively the following non-obvious, putative, general analytic connection between weak racial preferences and segregation. So the claim is here that you have in the back of your mind an analytic connection, whatever that is, I'm going to explain it to you, between weak racial preferences and segregation. And the robustness analysis is supposed to support inductively that analytic connection. So that all doesn't make sense, right? When you hear for the first time, this is crazy. Anyway, so, and the analytic connection that I claim is in the background of this model explanation is, under a wide variety of circumstances, the dynamics of weak X for X and weak Y for Y preferences analytically leads to XY segregation, right? What the analytically means, I'm going to explain it to you. So this is the point what I'm making. Abstract, the sentence in the middle, and then the concrete for the Schelling examples. What you want to argue for is that under a wide variety of circumstances, namely initial conditions in American cities and topography and blah, 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 right? Under a wide variety, the dynamics of weak preferences analytically leads to XY segregation. And I'm going to explain why analytically, what's the point of this analytically is. So you may say, oh, that has some connection to what we are talking about, but I don't understand what's going on. Okay, I explained that to you now in 5 points, I think, clarification and comments. First of all, what is an analytic connection? An analytic connection, the contrast term, is empirical connections. Two things may be analytically connected, or they may be empirically connected. Okay? Example 1 for an analytic connection. Being a bachelor and being unmarried. This is an analytic connection. If you analyze what it means, well, bachelor is now a very old-fashioned word, but single doesn't do the job, unfortunately, because you can be a single and married anyway. So being a bachelor really implies that you're unmarried. That's the definition of being a bachelor, right? And not a bachelor of science, a bachelor in social life, right? Okay, you may not even, well, I hope you still remember that old word, or you read it in old texts, that are digged out somewhere. Anyway, a bachelor is an unmarried man, usually, and not widowed and grown up and so on. So being a bachelor and being unmarried. So it's an analytic connection between these two. Once you are a bachelor, you are necessarily unmarried. Yeah? You don't have to investigate that empirically, right? By saying, oh, I don't know what's the connection between being a bachelor and unmarried. Oh, the best thing is I ask. I go and ask. Many ask, are you a bachelor? And then he says, yes. Are you married? No. And then you make an empirical investigation, and then you say, surprise, surprise, all these damn bachelors are all unmarried. Oh, that's interesting. No, it's an analytic connection. Huh? You can't call yourself a bachelor when you're married. You aren't one, right? So that's an analytic connection. So example 1. Next, being unmarried follows with necessity from being a bachelor, namely from the meaning of bachelor. That's just part of the meaning, so you can't play around with it. Otherwise, you don't speak the same language. Huh? It's just the meaning of bachelor, being unmarried, among other things. Here's the second example, and now it's not so obvious. being a Euclidean triangle and having an angle sum of 180 degrees. You may remember that. There's a proof for that. Right? There's an analytic connection. You can't have a Euclidean triangle that does not have 180 degrees angle sum. It follows with necessity from being a Euclidean triangle. Because being a Euclidean triangle means you have certain axioms of Euclidean geometry from which you can prove that the angle sum of Euclidean triangles is 180 degrees. So there's no way, it's an analytic connection. Analytic because you have to analyze the main term here. So if you analyze what it means to be being a bachelor, then you come to the conclusion, oh, then you're going to be unmarried. If you analyze what does it mean to be a Euclidean triangle, you can analyze it and then you come to the conclusion, not a very obvious one, oh, the angle sum is 180 degrees. So it follows with necessity from the terms that are employed. And here's now an example for an empirical connection. Say, thunder follows lightning. That could be principle. That could be different in principle, but it always happens. I mean, you see the thunder, you see the lightning, and then a little later comes the thunder. It could in principle be different. It is different in a vacuum, right? If you see lightning in a vacuum, you don't hear anything. Nothing. Don't. Yeah. It's different in vacuum. Therefore, it does not follow with necessity. This is new in these slides. I think different in vacuum. I've added that because that's a nice illustration. So it could be different and is different in a different situation. So it's an empirical connection, right? If you want to know, is there anything that typically follows lightning? Right? You say, lightning, what does lightning mean? More means light, electricity, blah, blah, blah. Oh, no idea. Okay. Of course, lightning, you see the lightning, but it doesn't follow that thundering comes out of that, right? It's produced by it. It's empirically. In our world, it happens to be that lightning produces thunders, but you got to investigate it empirically. You can't do it analytically by just analyzing what does lightning mean. So, analytic, and this is also a new sentence here, analytical connections are accessible to pure thinking, contrast to empirical investigation. Right? By just thinking about the concepts, you get the result, and you do not get that in empirical connections. Right? So the empirical connections, for instance, the speed of light is roughly 300,000 kilometers per second. You can think about the speed of light as long as you want. You never get to this number. Right? The number isn't included in the concept. You got to investigate it empirically. And so the same is with thunder. Lightning and thunder, but it's not the case with the bachelor and not the case with this empirical, with the Euclidean geometry. So an analytic connection is accessible to pure thinking. You don't necessarily need empirical investigation. But wait a minute, it's a little more complicated. So that's the first step, right? The difference between analytic connections and empirical connections. And you saw that in the main claim was that there is an analytic connection that's there. So the next step is, if you think there is somewhere an analytic connection, how to justify putative general analytic connections. Remember, I claimed there is a putative general analytic connection, and the question is, how do you justify them? If you say somewhere, oh, I think there is a general analytic connection, and then someone says, yeah, give me some arguments. And then the question is, how do you justify that? Okay, so first possibility may be obvious. If you speak the language, if you speak, in that case, English, and you know what a bachelor is in that, well, the other is also a social sense, in this personal sense, or marriage status sense, right? Then you know, oh, bachelor are those who didn't get, well, perhaps they didn't want someone. Anyway, they're unmarried, yeah, for whatever reasons. They're just unmarried. If you understand the language, and there's no damn discussion about it. Either you understand the language, then you know what a bachelor in that sense is, and then she or he is unmarried, period, right? She or he or number three. Anyway, so it may be obvious, right? The other possibility, that's of course the wonderful one for mathematics, all of mathematics has been doing that for 2,500 years, give a proof. So in the case of the Euclidean triangle, when you say, oh, that's very strange, triangles look so different, there are the big ones and the fat ones and the small ones, and all shall have 180 degrees. I don't believe it, this isn't that strange, my God. And you can turn them and then I say, come on, I give you the proof. And here's the proof, and then you say, oops, Yeah, no chance to deny that. So you give a proof. But this is not all. And now we come to the interesting cases, namely, and this is the cases not in mathematics, also partly in mathematics, but in other sciences, including, I think, economics, including theoretical physics, support the connection inductively by presenting examples. So you may have something where you think it's an analytic connection, but it's not obvious, like the bachelor case, and you can't give a proof, right? So do you have to give up? No, you don't have to give up. There is something else that's possible, namely presenting examples that inductively, then by generalization, support that analytic connection. I mean, in a sense, this is like fire and water, because analytic connections have nothing to do with empirical facts. They are just independent of them. But nevertheless, it is possible, if you have a putative analytic connection, that you say that you give inductive empirical arguments. Funnily enough, here's the example. Suppose you do not have a proof for the angle sum of 180 degrees for Euclidean triangles, as it was the case in Egyptian mathematics. Right? The concept of proof is an invention by the Greeks, and there was already mathematics before, 2,000 years, Mesopotamian and Egyptian mathematics, and especially the Egyptians had the Pythagoras theorem, how you you can construct a right angle, because they needed that for practical reasons. Well, it's very simple. You take a rope, and then you have 3 units, 4 units, and 5 units, and once you put them in a triangle, then you have a right angle between the 3 and 4, necessarily, because that's Pythagoras. And they found that out empirically, right? If you want to construct a right angle, you can do it very simply with a piece of rope. You can do it also with your parents, your grandparents, if necessary, or your children, or whatever. Anyway, so you can play around with it. So, and how do you find that out? Well, you play around, and empirically you do it, and you say, oh, it always works, right? The rope may be short, or may be long, or very long, just depending, and you always get the right angle. Wonderful. So that works. Suppose you don't have the proof, so you may inductively support the claim by measuring the angle sum of many different triangles, right? You say, well, probably, right, this is 180 degrees, but you don't have a proof, and then you say, well, let's try it out, right? So then you draw triangles many, and you always calculate and say, looks good, yeah. And what are you doing? Inductive. You do induction, right? This triangle has 180 degrees, this triangle, triangle, like, remember the copper case, right, conducts electricity, and I say, yeah, inductively. So you can inductively support analytic connections. And the connection between being a Euclidean triangle and having 180 degrees is analytic, as we know, because we know the proof. But if you don't know the proof, then you can do it inductively, empirically. This is what happens in mathematics again and again. It's never published, or practically not published, because that's not legitimate in mathematics. In mathematics, you're going to have a proof. But before the proof, you have a hunch, You say, oh, that could be a theorem, what I'm saying here. And you don't have the proof yet. And then you say, oh, wait, the proof may be very complicated. Let's first get some confidence whether it works for examples. And what you're doing then is you're building up, inductively some trust in the truth. And once you are fairly sure, you try very different examples, of course. And once you think, that is probably a theorem, that's true. Now let's go for the proof. Because then you are hopeful that then you have trust that there exists a proof. If it's false, you never find a proof, right? Because it doesn't exist. So in order to get some confidence that there might be a proof, because it's true, then you do that. So this happens in mathematics. I mean, not every day. Well, in some quarters of mathematics, probably also every day. But that happens in mathematics. But this is, of course, not proper mathematics. It's heuristics for mathematics. But in other fields, like in theoretical physics, and there I know really what I'm talking about, because something like that I did in my dissertation, that you have a certain hunch that there is a certain theorem, you can't prove it's too complicated, and then you try out a few models to get inductive support for that. So there is the second possibility is now, as the third possibility, how to justify putative general analytic connections by inductively giving examples that inductively support it. As I said, I've read that before, apparently. In mathematics, only heuristically legitimate. In theoretical physics, very common, because in physics, the mathematically, most situations are so complicated that you can't solve them analytically, by normal means. And then physicists are very, the mathematicians hate that because they say that's lyrics, more or less what physicists are doing there. Okay, so, now let's make a cliffhanger here. And 5 minutes break, and then we try to apply that to the case, in our case in question. 5 minutes break. All right, let us continue. I explained to you the difference between analytic connections from empirical connections. Then the next question was, if there is an analytic connection, how do I know that it holds? Then, of course, it's either obvious or you have a proof. There's also the possibility that you inductively justify it to some degree. You give it support. Justification of an analytic connection is, of course, a proof, nothing else. But you can say, yes, I can gain trust in the statement. And now we apply that to the justification of the claim that 2 slides before I stated, under a wide variety of circumstances, the dynamics of weak X for X and Y for Y preferences analytically leads to XY segregation. So the surprising term, 2 things are surprising here. The first is analytically, because we would believe that the connection between these weak racial preferences and segregation is empirical. Right? You investigate it empirical, or you investigate the segregation, and then there's this empirical connection, and therefore you get an explanation. You expect the explanation being empirical, right? And here it's said it's analytical, and what is also interesting is what is not said. Namely, there is nothing said in this sentence whether it applies to models or to the real world. It's completely devoid of any reference to what it applies. It just says if you have weak preferences of that kind, that leads analytically, namely with necessity, to weak racial preferences, right? If you aggregate, right? So there is no reference to model world, no reference to real world, nothing. It's nothing in there. It's an analytical thing. So the point is now, this is what I said, and now let's see what the arguments are for that claim then, and of course number 3 in the last point, it's the relevant one, because the claim is neither obvious nor there is a proof, try inductive support. Right? I claim it's analytic, well, you don't believe that, well, fine, but look, try inductive support, calculate as many single cases as possible with variation of as many inessential parameters as possible. Right? This is inductive support. Remember, when you don't have a proof for the angle sum in a Euclidean triangle, what you do is you calculate as many possible examples. And once you have calculated enough, you say, oh, well, I guess it's true. I don't have a proof, but that's good enough for the time being. So calculate as many single cases as possible. And again, it's not specified what sort of cases. You take, of course, those cases which you can calculate, which you can't do with Boston. Right? Because you don't know what Boston had developed, right? And all the data. So you take all the cases you can calculate, and then you get confidence. As the same when you go to the triangle case, right? And you calculate triangles, you will never calculate a triangle with 500 million kilometers the sides, right? Because you can't construct it, right? And then calculate. So you do it on a piece of paper, and then you calculate some, and then you say, okay, even if they get bigger, angle sum is not going to, it would be right. So you can't calculate all the cases. But you still get confidence after some sort of variation. You may still be wrong, because it's only inductive support. But that is exactly what you do here. Calculate as many single cases as possible with variation of as many inessential parameters as possible. Inessential being those that don't affect the fundamental concepts here, namely weak preferences and segregation. Right? So you can play around with these models and you calculate as many as possible. And when you find out, oh, interesting, in all the cases of weak racial preferences that could, produce a dynamics, oh, that's interesting. I always get segregation. Right? In other words, show that the resulting segregation is robust. So robustness analysis of the model is nothing but having many independent cases where you vary the parameters that are inessential in order to get inductive arguments for analytic connection. That's the new framing now, okay? So therefore, robustness analysis is an absolutely fundamental part of that whole story, because only robustness analysis shows you which are the relevant parameters to produce the effect. So in the case of weak racial preferences, there you see, if you leave that, and you can change all the other parameters in these two-dimensional models, and you can change the dimensions and whatnot, right? Even the colors of the chips, you can use green and red instead of white and black, for instance. Oh, what a change, wow. No, it's inessential for the dynamics, and then you get confidence, whoops, it's really the dynamics itself that independently of initial conditions produces the desired effects. You may discover that there are pathological, physicists call that then pathological initial conditions, which do not produce the result, and then you say, oh, let's forget about them, right? So in principle it works, right? So, but you've got to have a good feeling for that. So, show that the resulting segregation is robust. That's the robustness analysis of the model. So the point is, in my framing, robustness analysis gets a fundamental role, absolutely essential role. Without robustness analysis, no analysis of explanations, or potential explanations by models. Absolutely impossible. Because without robustness analysis, you do not know which parameter does the trick, produces that what you want to produce. And only by robustness analysis in the Schelling case model, you really start to know or get confidence that it's really the weak racial preference dynamics that does the job and nothing else, right? Because you can vary everything else and it doesn't have an effect. So robustness analysis is fundamental, and in any sort of explanation which robustness analysis doesn't play a role, it's got to be false, in my opinion here. Well, okay, crucify me later. All right, robustness I may show that under which conditions, if there are any, the model is invalid. This is something which a colleague of mine with whom I cooperate, Dunja Šešelja, she's now in Holland, I think, she was in Germany, comes from Serbia, and she told me that she works with agent-based models, and she said robustness analysis, may you also show you under which conditions the model is invalid. It shows you the limits of the model. So it can be that you see by robustness analysis, you vary certain parameters, suddenly something happens where you say, oops, I didn't think of that, and then it shows you, and then you see that you got to sharpen the constraints on the model. You just say, oh, under the following circumstances, the model produces this or that. Then you make restrictions, you add more presuppositions or suppositions for the model. So this is also important because sometimes you have surprises and the model does something which you didn't expect. And therefore, robustness analysis shows you where the limits of the model are, and then you can reformulate the model such that you exclude these limiting factors, and then the model becomes valid again. Okay, all right. So this was now number 3, robustness analysis. And now comes the trick. A true analytical connection can indeed be applied immediately to both model world and real world situations wherever the relevant concepts apply. All right. You are thus, this connection between weak racial preferences and segregation are independent of the sort of material things to which you apply it, because it is a conceptual connection, analytic connection. Wherever you apply these concepts, then this analytical connection holds. Take the example of The Bachelor. If you play some games in which game model bachelors, pieces of paper with bachelor on them, right? And they try to marry or whatever. And then you say something about these bachelors. They are also unmarried, right? Because it's an analytic connection between bachelor. So it makes, and if you are able to talk about Martians, I mean, there are possibly none, but anyway, if there were any Martians, as soon as you can say they are bachelors, it follows that they are unmarried. Because that's not a property of Martians, it's a property of the concept, right? The concept implies that bachelor being bachelor implies unmarried. And that's the same here. The thesis is behind this modeling approaches is that you get arguments for an analytic connection that gives you an analytic connection between weak racial preferences and segregation. And therefore, there is no application problem. It just doesn't exist because the connection is analytic. As I said, if you speak about bachelors and being unmarried, there is no application problem. As soon as you are able to apply the term bachelor correctly, that thing is unmarried because that's the meaning of bachelor, right? So the point is here, what you get here is that what seems to be the big problem is not solved but resolved. It just disappears. There is no application problem once you see that the relevant connection is analytic, right? That's the trick here. So analytic connection can be immediately applied. I hadn't seen that when I had, for the first time, talked about assumption A, where I said it could be immediately applied. I thought, yeah, this is an idealization which doesn't hold. I analyzed it later. And now it turns out, now, assumption A is the truth, right? Given that the rest of the analysis is right. So a true analytic connection can be applied immediately to both model world and real world situations wherever the relevant concepts apply. In other words, assumption A is... I know that. Okay, it's indeed valid if the analytic connection is established. That's right. And this is, at least to me, completely surprising. I did not think of that. Anyway, so, all right. And now, this is now the last step. You remember that if you have read, and of course all of you have read Sugden's article, where he says, when he discusses the two papers, the Akerlof paper and the Schelling paper, when he says, what sort of science is that? What's that way? How do they talk there? No empirical testing. I mean, this is pseudoscience in Popperini's. No, it is not. Why? Because if this analysis is correct, it may explain the oddities of economists' handling of models that Sugden describes, because once you find out by your modeling activities, you found out analytic connections, you don't have to care about applications because it applies immediately. So if you find out, say, in the used car market, if you find out that for this as asymmetric information situation, that a market doesn't develop or dies out very quickly, if that is an analytic connection, you don't have to talk about testing it empirically and so on, because you just find out, wait a minute, this is with necessity. This is if you put together asymmetric information and the situation of these cars and the used cars, if you put that together with these presuppositions, what the buyers do, what the sellers do, necessarily there can't be a market. Therefore, there is no application problem. And that sounds, of course, completely crazy, because the point seemed to be, and also in Sugden, that there is this application problem. And if that analysis is correct, there is no application problem. And that comes from the fact, or the supposed fact, this is what I'm arguing for, that the connection that is at issue here is analytic. And that does the trick, right? Okay. So let me go back, then I'll show you again what I said in the beginning, this very strange sentence, what I'm arguing for. That was here. So what you do is, third line, fourth line, support inductively a non-obvious, putative, general analytic connection. So this is what you do in modeling. You try to inductively support a non-obvious analytic connection that is analytic, right? And you show that then by inductive arguments, by robustness analysis of the models. That's the idea. And the trick is here by seeing, or the centerpiece is here, that the connection is analytic. And most people, me included, for decades, and I've argued against it for decades. I always thought, if you have an explanation, the explanation in the empirical sciences must be empirical. It can't be something analytic. Something analytic cannot explain anything. This is what I thought, until recently. And I argued, I know exactly, 10 years ago at the Institute, there was a guy, and he was doing biological models, and then he said, no, Paul, this is analytic. I said, nonsense. bullshit. It can't be. I mean, I know what empirical sciences are. Don't tell me they're analytic connections. Forget it, right? So I couldn't believe it. And also, in evolutionary theory, there's this problem with the so-called tautology objection. Tautology meaning saying the same things. So the tautology objection to selection theory, Darwinian selection theory, is when you say what is fitness? Fitness. The fitness that the fitter individuals survive and have and so what is fitness? Well, the fitness means that you have more children, right? What's the technical term? Nachkommen, more descendants. Yeah, more descendants, right? So that's fitness. And then you say, the survival of the fitness, and the fitter one survives better. So the theory says the survivor of the survivor. Right, so, wonderful, Darwinian theory says the survivor survives. Oh, what a fantastic scientific theory. So that's the tautology thing, and I always thought, you have to define then fitness independently. This is what people usually do. You must define fitness independent of the rate of descendants that you produce, and that can be done. But anyway, there is this analytic element, and I know that. I mean, for decades I have fought that and said, no, that's nonsense. Can't be the case. Well, it seems that this is not completely right, because there may be analytic connections that are indeed explanatory, right? But they are so non-obvious, and you can't give a proof for them, that you somehow have to support them. And as I said, I mean, when you think about it, that, say, weak racial preferences and segregation, when you think about it, I mean, what does it mean with these weak racial preferences? Well, it means that people move away from situations with too few members of the same race or same color. And then you say, okay, I mean, you don't really see immediately that this really leads to sharp segregation. You may say that may lead to some segregation, right? But then you look at the models, right? And you play around with the models, with the parameters, and then you see, wait a minute, it always leads, as long as people can move, it always leads to sharp separation in the models. And then you say, there is this non-obvious analytic connection. I mean, a model is always analytic, right? It's pure, it's logical deduction. You have initial conditions, dynamics, and then, of course, it follows logically. There's nothing empirical in the computer. It's completely logical. It's absolutely. What you don't know is when you run the model only once, you don't know what the fundamental factors are, the relevant factors. About Friedman spoke, you've got to find the real factors that do the job, and you've got to somehow get rid of the inessential factors. This is what robustness analysis does. That preparates, that where Friedman said, these are the causally relevant factors that do the job. The relevant forces is also an analogy to physics that's used here. And this is what you do in robustness analysis, and then you get a feeling what the relevant factors do, and you only get analytic connections, because a model is a mathematical calculation. You put something in there, and then it follows with necessity from the algorithm. So it's mathematical. It's purely mathematical, nothing empirical in it. And therefore, of course, you get these and these singular analytic connections from the singular models. You can use them as inductive supporting a very general analytic connection. So this very strange sentence here that you inductively support non-obvious putative general analytic connections. That is the trick, and this is now my story about how models work. They do that, and now let's see how we can continue, because that's not the end. We are still here in... So, the logic of the transfer, now the logic I told you, logic meaning here the connection, the mechanism. So the logic of the model-based explanatory practice, and this is the normal way, how it was done with suction and after suction. The normal way is this: you have model results, you get potential explanations, right, in the model world, and then you have this problematic transfer to the real world results, and there you get, in the very best case, assumption A, potential explanations. But then you have to somehow be clear how that works, because it's problematic. Possibly you get less than potential explanations, right? Because you have the model world, and you don't know whether that really applies over there. So this is the common picture. And here is now the minority picture of, I don't know how many philosophers economics, so it's possibly 1 per mil or something. The picture is now such that you have robust model results, right? Robust model calculations. They inductively support a non-obvious analytic connection. If it was obvious, you wouldn't need it. Obvious means you just see it, like with Batchelor. But you don't see it immediately in the case of weak racial preferences and hard segregation. You don't see that. It's just, well, I don't know. But then you get inductive support that there is this non-obvious analytic connection. And because it's an analytic connection that does not depend on subject matter, it depends on the concepts, you can immediately apply that to the model world, where you get potential explanation, and to the real world, where you get potential explanation. So what we get from the Schelling model, if it's robust, and it seems to be, that we get immediately a potential explanation for racial segregation, which is, in a sense, if you don't think about it, obvious. Right? This is how people reacted. They read the Schelling model and says, oh, wow, that's a potential explanation for the American cities. You see that immediately. But once you are asked, hey, wait a minute, how's the transfer going? You say, oops, oh, that's complicated. I don't understand a word, right? Because you don't see that this is an analytic connection. If I'm right, if I'm wrong, that is, of course, all rubbish. But if I'm right, then you can understand these things. Okay. So, if that story holds, then what we get is from model calculations, and especially from the robustness of the model calculation, we get inductive support for analytical connections, and these analytical connections therefore show us that there are potential explanations around that we get from the models. By that, we are, of course, not completely happy, because we don't want to have a potential explanation. We want to have the real explanation, right, for a phenomenon. Not saying it could be like that, or it could be like that. No, I want to have the answer. Explain that phenomenon to me. Okay.